Hey Science 2 kiddos, going to use these slides to quickly review climate change and the Hewitt reading you did on that. So one of the two vocabulary terms that came from the reading was carbon sources and carbon sinks. And those are exactly what they sound like. I know sinks is a weird word to use, but carbon sources are anything that is putting carbon dioxide into the atmosphere. So chief among what a lot of you are familiar with is burning coal in power plants or exhaust from cars. That adds a lot of CO2 and other greenhouse gases to the atmosphere. That's why we call them sources. Sinks are anything that remove carbon dioxide from the atmosphere. So obviously plants, by performing photosynthesis, are actually taking carbon dioxide and converting it into sugar, which we then eat. And there's a couple other things too. Believe it or not, ocean water actually will absorb a lot of carbon dioxide as well. That's why we get what's called ocean acidification. A couple other different things. And obviously there's a problem when the sources become larger than the sinks, and that's what's currently going on in the world, right? Is that by deforestation, cutting down trees, we are definitely, and by driving cars more often and burning more fuel for electricity and things like that, we are definitely drastically increasing the sources, the amount of CO2 being released into the atmosphere, while simultaneously reducing the sinks, which is not a good combination. Now, I want to emphasize, though, and a lot of you are familiar with this, right, that these, what we call greenhouse gases, carbon dioxide, methane, water vapor, are good at trapping the solar radiation that comes from the sun, right? So there's a lot of warmth coming from the sun, and it enters our atmosphere, and some of it gets trapped inside. However, this is a good natural thing, right? This is something that needs to occur. This is one reason why we have an environment on our planet that we can survive in, right? So we don't want to just eliminate greenhouse gases, right? You sometimes read that we should just get, lower CO2 as much as possible. That if that happened, we would all freeze to death, right? It would be way too cold. We do need these greenhouse gases to trap some of the warmth in the atmosphere to keep water in liquid form and allow life to survive. Problem is that we are now getting too much of these greenhouse gases, and it's sort of offsetting that balance. So you can measure what's called global warming potential. It's basically just how good these different gases, so carbon dioxide, methane I mentioned, fluorides we'll talk about, how effective are they at trapping heat. And so carbon dioxide, you can see, is actually pretty low on the scale. But just to give explain a little bit. So carbon dioxide, is CO2, and actually has a molecular structure that looks like this. It's an oxygen double bonded to a carbon, double bonded to another oxygen, and it's those bonds right there that are able to absorb energy. So basically solar radiation, I'll draw it like that, can enter these bonds, and basically what happens is they vibrate back and forth, kind of like a spring, or like an accordion almost, going back and forth, and that's how energy gets trapped into these CO2 molecules that they can then emit later. So it's we are kind of familiar with how this works on a molecular level, and that's what's also happening in things like methane, right? Methane is CH4, so it's also got carbon with 4 hydrogens all around it, and again, those bonds can sort of, again, accordion or spring back and forth, and that's how they trap solar radiation, heat energy that's entering our atmosphere. And so obviously you can see that these fluorinated gases are very, very effective, for whatever reason, at trapping heat in our atmosphere. It's going to come up a little bit later. But this is basically what you call the greenhouse effect, right? Where our atmosphere has carbon dioxide, water vapor, methane, and other gases, and they are very good at trapping and re-releasing warmth within our atmosphere, which again is a natural process that is needed for life to continue, but we are now releasing too much of these gases into our atmosphere, and so we're seeing a gradual warming of our planet. So here's the famous graph. This is looking at carbon dioxide concentrations over time. This was all measured at a station in Mauna Loa in Hawaii. And so this variation is occurring just because there tends to be a bit of an increase in CO2 concentrations in the warmer months and a decrease in the colder months. But hopefully you're noticing that there's definitely been a marked increase steadily over time. And now global temperatures aren't reflecting this perfectly, and there's a couple explanations for that, but it's hard to argue with this that we are definitely drastically increasing the amount of carbon dioxide in our atmosphere. So those studies were started in 1960, so we have data from 1960 onward. how can we get data about CO2 concentrations in the atmosphere before that? And it turns out that one way to do that is look at ice cores. So in the Arctic and Antarctic, ice has been freezing. You can almost, everyone see the stripes here? There's layers of ice. And it turns out that gas bubbles have been trapped in that ice. And so what scientists can do is take ice cores. They basically take these long tubes and they stab them all the way down, then lift them out, and then here you've got layers of time with these gas bubbles that are present that can then be analyzed to figure out, well, what was the CO2 concentration in the air in those gas bubbles that were trapped during that year. So they can use carbon dating and things like that to figure out how old it is and then measure concentrations, and which is pretty fascinating. And so Arctic or Antarctic samples have gotten data from about 1,000 years ago, right, from starting from year 1000, and you can see that CO2 concentrations were pretty consistent right up until, again, the Industrial Revolution, and now suddenly we're seeing this giant increase. So that kind of, I think, makes it a little more drastic when you see that larger time scale. But here, again, is the graph that really gets me. So this is based on data from Vostok Ice Core. I'm not entirely sure where this is collected from, probably in the Arctic somewhere. But they have data going back 400,000 years. And you can see that there's sort of been natural variation, right? This rise and fall, there's ice ages and things like that. But the highest ever recorded, about 300,000 years ago, was about 300 parts per million of CO2 concentrations. Again, look at today. That's where we are right now, at about 400 parts per million. This is 100 parts per million higher than at any time in the last million years, apparently. So going to be interesting to see what the consequences of this are. We are in a novel situation for our atmosphere. So the reason we refer to this as global warming is because you can see in this graph here, carbon dioxide concentrations are measured in blue and global temperatures are measured in red. And what I'm hoping you'll notice is that there's a pretty clear correlation between the amount of carbon dioxide in the atmosphere and the average global temperatures over time, right? With some variation, obviously. But again, here we are. Here's where global temperatures have been, but here's where CO2 concentrations are. So what's going to happen? Is our global temperatures also going to spike like that? Which would be pretty dire. Now, many people believe that climate change is still a hoax. I've liked this picture a lot, right? I don't believe in global warming. Notice global warming is flooding, probably because of rising sea levels due to melting glaciers and things like that. The chief argument is that it is correlation, not causation. In other words, it's really just chance that CO2 concentrations and global temperatures line up like that, right? And so, you know, here's kind of a funny one that here's another graph, and you can see there's a clear correlation between, in red, U.S. spending on science, space, and technology, and in white, suicides by hanging, strangulation, and suffocation. I guess a lot of scientists are just killing themselves. No. Obviously, these two things are not related to each other at all. It's just what's called a correlation, right? That you can graph them with scales like this to look similar to each other. However, again, I would argue, and you'll hear a lot of scientists argue, that this is not correlation with climate change, it is causation. And there's a lot of different things, right? Again, knowing the molecular structure of carbon dioxide, and again, I mentioned that kind of springing motion that the bonds do, that they're able to absorb solar radiation and then re-release it. Methane does the same thing. There's definitely behaviors that these gases exhibit that they're trapping energy, right? And so global temperatures have been increasing and changing over time, specifically in the northern poles and southern poles, right? You can see there's been a difference of about 4 degrees Celsius, which is crazy. I think temperatures are getting much warmer than they normally would in those regions. So you looked at your own personal contribution, right? We looked at transport, home use, contributions, food, and purchases. And you'll be analyzing, or you should have analyzed that data and looked at how the class did overall. It definitely seemed like transportation was the biggest contributor overall, and personal purchases was actually the lowest, right? So this was very low. Transportation was very, very high, and that's probably because of carbon emissions from airplanes and cars and things like that. So here are a couple things that you can do, right, to affect emission savings, right? If you really wanted to cut back on your personal contribution to your carbon footprint, then there are things like, again, you can upgrade your light bulbs to be LEDs or things that are more environmentally friendly. You can recycle more. You can become more vegetarian, eat more plant-based diets. You can invest in green energy, that kind of thing. But the biggest thing you could do is have one less child, which again is not something a lot of people are willing to do, but has drastic carbon dioxide reduction savings, right? It's partly just population growth that seems to be contributing to increase in carbon emissions. Now again, CO2 is what you hear about all the time, but it's not the only greenhouse gas. In fact, these fluorides, so chlorofluorocarbons called CFCs and hydrochlorofluorocarbons, were discovered to be very, very good at absorbing solar radiation. These were banned in 1987 because they were also contributing to the reduction of the ozone layer. These were used in a lot of appliances, refrigerators, air conditioners, that kind of thing. So these have all been banned. They're not in wide use anymore. We're reducing their levels in the atmosphere. But refrigerators and air conditioners didn't go away. They just replaced these chemicals with another chemical, which are called hydrofluorocarbons, or HFCs. And so these are not banned, but they're very similar to those ones I just mentioned. And the same thing, they have these bonds in them that, as far as I know, do the same kind of accordion back and forth behavior, but they are 10 times more potent at absorbing solar radiation and heat and contributing to global warming than CO2. And so these are not a good thing to have in our atmosphere, and they're getting into our atmosphere chiefly from leakage from refrigerators. All that kind of tubing in the back of your fridge, if you've looked in the back of your fridge, there's this weird kind of wire structure there, is full of this fluid of these hydrofluorocarbons. And so this is what we need to avoid, is refrigerators just being dumped, broken, buried. That is releasing those hydrofluorocarbons into the air, which are drastically contributing to global warming, right? Refrigerators need to be recycled. The chemicals need to be properly disposed of to make sure that they don't get into the atmosphere. Okay, I want to end with just a little personal story. I served in the Peace Corps right out of college back in 2008. Peace Corps is a government organization that sends volunteers overseas for 2 years to countries that have requested them and do work in various areas, education, agriculture, health, small business, that kind of thing. I was an education volunteer. This is kind of what led me to teaching. I served for 3 years, actually, in a tiny country called the Gambia in West Africa. Here's Africa right there. There's Gambia. It's a very tiny country right there. And I was stationed right there, about as far up country as you can get. So that was kind of, considered the middle of nowhere, a very rural place. I was a science teacher in a village school. And so, yeah, I lived for 2 years in this. This was my thatch roof hut. Notice there's no power lines. There's no plumbing or anything like that. And so this was a time in my life when my carbon footprint was actually, if you ignore the flights that were required to get me to Africa, my carbon footprint was pretty low for those 2 years. The only energy I had was a solar panel that I put on the roof of my hut, and I had a little wire that went down into a car battery that I had inside, and I was able to use that to charge a cell phone and my iPod and things like that. Cooking, again, there were no gas stoves or anything like that. The wood was just burned. And so, granted, that's definitely going to contribute CO2, but nothing compared to, using a fancier stove would or a gas stove. Water was not pumped to the house or anything like that. It just came from these hand crank pumps. You can see how worn down that hand pump is. Then you just hauled it in these little containers that were called bidongs. And these were refrigerators, so no hydrofluorocarbons here. These were just clay pots, and we learned about evaporative cooling. So you'd fill these with water. The water would sweat out of the clay and would evaporate, and it would actually cool down the water on the inside. Now, it's not like a actual industrial refrigerator, but it did make the water cooler than the outside temperature, which was nice. Washing water came from open wells, so again, this is not water that I would drink because animals sometimes fell in here, chickens and bats and things like that would be dead and floating in the water. But it was water you could use to bathe yourself, and had to haul it up there. But again, nothing pumped or anything like that. I just had to do that myself. I also tended to avoid the vehicles just because the roads were really gnarly and the vehicles were not in very safe condition. And so Peace Corps didn't provide us with, Peace Corps provided us with bicycles to ride, really, really good ones, trek bikes that were really tough. And so, yeah, that's how I got around. And, if I ever had to go down to the market areas to buy food, I would just load up as much as I could on my back, on the front of the bike, and so on. And so I rode everywhere. Actually did not do very much car riding, which I think definitely decreased my carbon footprint. Food was all locally farmed as well, so all the food I ate had not traveled from very far away, unless you included some of like the donated rice and stuff like that, which is coming from like United Arab Emirates or World Food Program. Fruit, there's lots of fruit to eat. These are mangoes. They're mango season. These are baobab fruits. If you've ever had those, they're really good. That right there is actually a cashew fruit. So the cashew nut is right there, but a lot of people don't realize that cashews also have a big fruit. It's very, very acidic and tart, but actually very good if you... and we gardened a lot of vegetables and stuff. I actually grew quite a few during my service there. So again, all things that definitely I think decreased my carbon footprint, or at least compared to what my carbon footprint today is. Okay, hope this was helpful. Thanks.